Hello, good day everyone. I am Clint Grace Cabanlet from BSHM 1B. I'll be the one to report the graph coloring from Module 6, Section 4. For this topic under graph theory, which is graph coloring or how to color graphs. To color a graph, one must draw a graph in such a way that no edges are intersecting. This is now what you call a planar graph as shown. If at least two edges intersect with one another, we now call this graph as a non-planar graph as shown. What is graph coloring? Graph coloring, a coloring of a simple graph, is the assignment of a color to each vertex of the graph so that no two adjacent vertices are assigned the same color. What is a graph? A graph is a collection of points called vertices or nodes and connecting segments called edges. Sometimes the edges are given orientations and are represented by arrows or are given values weights. The position of the vertices, the lengths of the edges, and the shape of the edges do not matter in a graph. What we look at is the number of vertices and which of them are joined by edges. Chromatic number. The chromatic number of a graph is the last numbers of colors needed for a coloring of this graph. The four-color theorem. The chromatic number of a planar graph is no greater than 4. These are some of the ways any number of vertices can be placed in a plane or drawn as a planar graph. In any planar graph, we use Euler's formula to determine how many vertices, faces, or edges can be present in a planar graph depending on what is being asked. Usually, it's the face twist this formula. V plus F is equal to E plus 2, where V is the number of vertices, F is the number of faces, E is the number of edges, then 2 is a constant. If you're looking for the number of faces so that you can draw your graph in a planar manner, you simply identify F is equal to number of edges plus 2 minus the number of vertices. So, example, if F is unknown but the vertices and edges are known, so V is equal to 6, E is equal to 9, so you have 6 plus the number of faces is equal to 9 plus 2, so 6 plus F is 11. Therefore, F is equal to 5, so shown there are 5 faces, including the outside face colored yellow. In graph coloring, each vertex of a graph will be assigned one color in such a way that no two adjacent vertices have the same color. The interesting idea here is to determine the minimum number of distinct colors to be used so that we can color each vertex of graph with no two adjacent vertices. The chromatic number is the minimum number of colors needed to color any graph. If a graph is planar, the maximum chromatic number is always 4. Graph coloring is usually used in a scheduling problems like this one. So, 6 college accreditation committees need to hold meetings on the same day. But some teachers belong to more than one committee. In order to avoid members missing meetings, the meetings need to be scheduled during different time slots. An X in the table indicates that the two corresponding committees share at least one member. Use graph coloring to determine the minimum number of time slots necessary to ensure that all faculty members can attend all meetings? You can pause this video if you want to answer this problem on your own. First, you draw a graph representing the 6 committees using 6 vertices or nodes in any configuration, and each connects 2 committees that share at least one member. Then, assign each vertex of the graph with one color in such a way that no 2 adjacent vertices have the same color. Answer is shown. We have 3 as the chromatic number. Hence, the minimum number of time slots necessary to ensure that all faculty members can attend all meetings is 3. So, a schedule of meetings, first time slots, faculty instruction and student welfare. For the second time slot, faculty development and outreach program. Third time slot, library facility and physical facility. So, here are some other examples. Construct the dual graph for the map shown. Then find the number of colors needed to color the map so that no 2 adjacent regions have the same color. As we can see in the left portion, we have the A, B, C, D, E, and F. So, as we can see at the right portion, we have A, which is colored yellow, B and the F and D are in a color violet, and the letter C and E is color green. So, at least 3 colors are needed to color the graph because of triangle ABC exists in the graph. Next, find the chromatic number of the given graph. So, letter A, B, C, and D. At the right portion, we have the colored violet for letter B, A and C are green, and the letter D is colored yellow. Since the graph forms 2 triangle ABD and triangle BCD, we can color the graph with at least 3 colors where A and C are the same colors. This graph can be colored with 2 colors like shown. So, as we can see at the right portion, A and C are colored green, and B, E, and D are colored violet. The mathematics department has 6 committees, each meeting once a month. How many different meeting times must be used to ensure that no member is scheduled to attend 2 meetings at the same time if the committees are C1, Arlinghouse, Brand, and Zaslavsky. C2, we have Brand, Lee, Rosen. For C3, Arlinghouse, Rosen, Zaslavsky. For C4, we have Lee, Rosen, and Zaslavsky. For C5, we have Arlinghouse and Brand. And for C5, we have Brand, Rosen, and Zaslavsky. So, we will first draw the interesting graph of the given sets. We have C1, C2, C3, C4, C5, and C6. From here, it is easy to see that we need at least 5 colors like so. C1 is colored with yellow. C2 is colored with violet. C3 is colored with color green. C4 and C5 are colored with orange, and C6 is colored with red. Therefore, 5 meeting times are needed. Committees C4 and C5 can meet at the same time. So that's the end of my report. Hope you learned and understand from the topic that been discussed, and thank you for listening.